Hello everybody. Now, as I told you, in this lecture, we are going to focus for the equation of polarographic wave. Equation for polarographic wave. Okay, so this is what the polarographic wave which we observe on the screen. Okay, polarographic wave. So the polarogram is a plot of current versus applied voltage. Current versus applied voltage. Hence, the equation will be mathematical expression which gives the relationship between the current flowing with the applied voltage. That will be the relation between current flowing with the applied voltage. Okay, so this is what we are going to link over here. Now, see, consider a general redox system. Okay, see, this is what the oxidized form, when it takes the electron, it is going to reduce. It is going to reduce. And if we apply the Nernst equation, or if we apply the Nernst law, what happens here? E system, okay, is equal to E standard of, okay, E standard of a system minus 2.303 RT upon NF into log of concentration of reduced form of the species upon concentration of oxidized form of the species. Okay, E system is equal to E naught system minus 2.303 RT upon NF into log of concentration of reduced form of the system upon concentration of oxidized form of a system. Okay, where this is a concentration of reduced form, this is a concentration of oxidized form of the constituent. Okay, so as we know that current is a diffusion control, therefore rate of a diffusion is proportional to current. Rate of a diffusion is proportional to the current, but the rate of diffusion depends upon the concentration gradient established. That is the concentration difference between the bulk of the solution and the electrode surface. Concentration difference between the bulk of the solution and the electrode surface. Okay, therefore rate of diffusion is proportional to I is proportional to oxidized form, concentration of oxidized form in the bulk, okay, into concentration of the oxidized form at the electrode. Okay, so this is at the electrode surface and this is at the bulk. Okay, therefore this can be written as, okay, current is equal to, we can write here, equal to K1 into oxidized form in the bulk upon oxidized concentration of oxidized form in the electrode. Okay, now where OX bulk and OX electrode indicates the concentration of electroactive species in the bulk of the solution and at the electrode surface. OX bulk indicates this one and OX electrode indicates the concentration of oxidized form or electroactive species, we can say in short. Okay, so this is what the electroactive species in the oxidized form, we can say. Okay, so the E electrode in this in the at the electrode surface, this is the concentration at the electrode surface. Okay, and this is the concentration in the bulk, right? The constant of the proportionality K1 can be obtained. Now, from this equation, for above equation, K1 can be obtained using Ikovic equation. Okay, then the concentration of the electroactive species at the surface of the electrode become equal to zero. The current become equal to diffusion current. Current will become equal to the diffusion current. Okay, then see, this is what the concentration at the electrode surface, concentration of electroactive species at the electrode surface become equal to zero. In that case, what will become? Current will become equal to the diffusion current. कारण आता इलेक्ट्रोड सरफेस वरती कॉन्सन्ट्रेशन काय झालं, इलेक्ट्रोएक्टिव्ह स्पेसिसचं झिरो आहे, म्हणून आता जो काही करंट मिळणार आहे दॅट इज ड्यू टू द diffusion current. Okay, so ID is equal to K1 into concentration of electroactive species in the bulk. Okay, now this is at the electrode surface, that become equal to zero. Therefore, we can write ID is equal to K1 into concentration of the electroactive species in the bulk. म्हणजे जे की बल्क म्हणजे काय, सोल्युशन आहे असं समजा. हे टेस्टिंग सोल्युशन आहे ना, याच्यामध्ये किती कॉन्सन्ट्रेशन आहे असं समजा, हे बल्क कॉन्सन्ट्रेशन आहे. ओके, याच्यामध्ये जेवढे असतील तेवढे. Okay, therefore electroactive species in the bulk is equal to ID upon K1. ID upon K1. Now, electroactive species, concentration of electroactive species in the bulk is equal to ID upon K1. That we are going to put over here. That we are going to put over here. Now see, this is what I am taking from. Okay, this is what I am taking from here to here. Okay, so equation, putting for equation 4 and equation 3, what we will get here now? I is equal to K1 into electroactive species in the bulk minus K1 into electroactive species at the electrode surface. Okay, this is what we got from the equation number 3, where we put the equation number 4. Therefore, ID is equal to K1 into electroactive species at the electrode surface. Okay, the equation इथे टाकल्यानंतर आपल्याला equation भेटते. Therefore, what you can write here, K1 into electroactive species at the electrode surface is equal to ID minus I. है ना? हे जे आहे हे इकडे शिफ्ट केलं, ओके, आणि हा I जो आहे इकडे शिफ्ट केल्यानंतर we get this equation. Okay, therefore, electroactive species at the electrode surface is equal to ID minus I upon K1. ID minus I upon K1. Okay. Similarly, the amount of reduced form obtained will depend on the current passes through the solution. In accordance with the Faraday's law, Therefore, I is proportional to the reduced form of the species or concentration of reduced form. This is what that is equal to current. When metal ion get reduced to the metal ion get reduced to the metal with the DME as a cathode, it forms an amalgam with the mercury, or whatever mercury drop is falling in the solution. The metal remain dissolved in the mercury. Therefore, I is equal to K2. I is equal to K2 in the concentration of reduced form at the electrode surface. है ना, ते मेटल ज्या इलेक्ट्रोड सरफेस वरती रिड्यूस होत आहेत ना, तिथलं देत आहेत. काय इथं काय बघा, इथून सुरुवात आहे, कुठून, इथून. अमाउंट ऑफ reduced form obtained will depends on the current passed through the solution in accordance with the Faraday's law. आता कोणाचं बघतो आपण, अमाउंट ऑफ रिड्यूस फॉर्म. ओके, हे कसलं होतं, अमाउंट ऑफ ऑक्सिडाइज फॉर्म या ठिकाणी मिळालेला आहे आपल्याला इक्वेशन 5 मध्ये. आता अमाउंट ऑफ रिड्यूस फॉर्म काढतोय आपण, प्लीज डोंट गेट कन्फ्युज. So from here onward we are looking for the amount of reduced form. I is proportional to concentration of reduced form. Therefore, I is equal to K2 into concentration of reduced form at the electrode surface. Okay. Therefore, from above equation, what we can find, concentration of reduced form at the electrode surface is equal to I upon K2. You are shifting this to the denominator. Okay. Therefore, I upon K2. Okay. Therefore, and what you have, you have amount of oxidized form of electroactive species at the electrode surface, or amount of electroactive species at the electrode surface. That is ID minus I upon K1. Okay, this is from equation 5. Okay, now put these two concentration. Okay, so you can divide equation 6 by equation 7. What you are getting here, this one, this equation. What you are getting, this equation. Divide equation 6 by equation 7. Divide equation 6 by equation 7. Why we are dividing? Because we have to carry this value to the equation which is given at the beginning. Okay, here, see, here this equation. Okay, over here we are going to come. Okay, now see, taking this to that equation. Which equation? Equation number 2nd. Okay, what we are getting here, see now. E system is equal to E naught system minus 2.303 RT upon NF into log of concentration of electroactive species at the electrode surface. Okay, this is what the electroactive species. This is a reduced form. Okay, this is a reduced form. This is an oxidized form of electroactive species. This is a reduced form of electroactive species. Putting that over here, what is that? Log of K1 upon K2 into I upon ID minus I. Remaining is the same. Now we can solve this equation. Okay, So E naught system is equal to 2.303 RT upon NF into log of K1 upon K2 minus 2.303 RT upon NF into log of ID upon हे स्प्लिट केलं आपण या दोघांना स्प्लिट केलंय म्हणून तिथे काय आलं मायनस साइन आलेला आहे बिकॉज दिस कंटेन्स मायनस साइन तर इथं प्लस असतं तर या दोघांमध्ये प्लस आलं असतं म्हणून पुन्हा काय करतो आपण 2.303 RT upon NF log of ID upon ID minus I. But we know that when I become equal to ID 1/2, the last term will become equal to 0. How? Put I is equal to ID by 1/2, ID by 2. See, ID putting there ID by ID upon 2, and I is equal to ID by 2 or ID 1/2. Here ID minus ID 1/2. Okay, putting here I is equal to ID by 2. Only we are putting I is equal to ID by 2. Huh? We are not changing ID term. So that will become, so ID 1/2 will remain as it is, but this is ID minus ID by 2. म्हणजे एकातून अर्धा गेला तर अर्धाच राहील म्हणजेच ID by 2. So that will become ID gets cancelled 1 and log of 1 is 0. So this term will become equal to 0, whole term. This whole term will become equal to 0. Therefore, above equation can be written as E system is equal to E naught system minus 2.303 upon 2.303 RT upon NF into log of K1 upon K2. But we know that as I become ID by 2, then E become E1/2. Even E will become E1/2. That is equal to E1/2. Okay. Now, what is E1/2 equation? This is E1/2. This is E1/2 when your ID equal to ID by 2, then E become equal to E1/2. So put this over here. ओके, हे जे इक्वेशन आहे आता त्याच्यामुळे हे काय असेल आपला E1/2 असेल. मग ही अबव इक्वेशन जी आहे काय होणार किंवा ही इक्वेशन काय होईल आता बघा. ई सिस्टम इक्वल टू E1/2 minus 2.303 RT upon NF into log of I upon ID minus I. See, E system is equal to E1/2 minus 2.303 RT upon NF into log of I upon ID minus I. Okay. Or if you take this is a numerator and this is, if you take a denominator to the upper side or numerator, okay, or if you reverse this, there will be the positive sign and you can write this equation also like this. E system equal to E1/2 plus 2.303 RT upon NF into log of ID minus I upon I. Okay, this is how you can write the equation. Okay, so the equation is used to test the reversibility of the electron reaction. The equation is used to check the reversibility of the reaction. Only reversible electrode reaction will obey the equation, right? Slope of the straight line obtained by plotting E1/2 versus log of I upon ID minus I can be used to calculate the value of N. What is N? Are the number of electron transferred in the process. The equation can be used both for cathodic and anodic wave. By convention, the cathodic current is assigned positive sign and anodic current is assigned with the negative sign. Anodic current assigned with the negative sign. Okay, so it represents the cathodic and anodic waves produced for a given system. It represents cathodic and anodic waves produced for the given system. Okay, so cathodic and anodic waves. There is a cathodic and, so for the cathode, you can see this is in the upper side. Okay, and for the anode, this is in the downward side. Okay, see how the wave will become like this. Okay, so this is what the equation. Okay, and we can check the reversibility of the electron reaction. See how, है ना, दिसतंय ना त्या ठिकाणी जसा पार्ट वरती आहे तसाच पार्ट काय आहे खालती आहे. Okay, reversibility of the reaction. Okay, so in the next lecture we are going to start the ionic equation. So for this lecture we have studied the whole equation from here. Okay, equation for polarographic wave. Equation for polarographic wave. And this was what our final equation for the polarographic wave. This is very important equation. Okay, so I'm going to stop here. Remaining, I will continue in the next lecture. Thank you.